All right, today we're going to go ahead and get into section 9.3 notes, continuing with area of figures. All right, so far we've looked at area of three-sided figures, area of four-sided figures. Today we'll focus on area of circles. All right, so we'll be able to find the area and circumference of a circle, and then we'll be able to find the arc length and area of a sector. All right, so let's go ahead and get into our formulas for today. First one is circumference. Now we can look at circumference one of two ways. We can look at circumference being either pi times d or 2 times pi times r. So if we're given the diameter, we could just do diameter times pi. If we're given the radius, we can do 2 times pi times r. All right, the circumference will tell us the length around the circle. Now, if we want to find the area of the circle, then we'll switch over to our next formula. Our next formula says area of a circle is pi r squared. So A equals pi times r squared. Remember, r is the radius. Remember, in your picture, diameter is the whole line, radius is half of it. So let's go ahead and remember a couple of things so that we plug in the right number into our formula. If they give us the diameter of 24, so they tell us the whole entire line is 24. If we want to find the radius, we need to cut that in half, so the radius is technically 12 inches. All right, let's say they gave us the diameter again. All right, diameter is the whole entire line, so if they give us the whole entire line, in order to find the radius, we'll cut it in half. Half of 50 tells us 25 centimeters. Now remember, the other way, if they told us the radius, so they told us part of the line is 10, they want us to know the whole thing. Well, 10 times 2 will tell us the whole thing is 20 feet. All right, same thing, if they tell us the radius and they ask us to find the diameter, then we need to double it, so we would be at 34 centimeters. All right, so it's important that we can identify our radius versus diameter. And now let's go ahead and look at some examples. Find the area and circumference in terms of pi and rounded to the nearest tenth. All right, so in terms of pi, so circumference, our formula says pi times d or 2 pi r. Now you'll notice in our picture they give us a diameter, so I'm going to use the pi times d. So to find circumference, I'm going to do 6 for diameter and then copy the pi. If I leave it in terms of pi, I'm not multiplying the pi. Leave the pi in the answer, so my circumference would be 6 pi. If it wanted nearest tenth, I would multiply 6 times pi, which is going to give me approximately 18.8 inches. So in terms of pi, we don't multiply it. In terms of nearest tenth, we multiply everything. Now, let's say it asks us to find the area. Well, we know area formula is pi r squared. Well, if the diameter is 6, I need to cut it in half and make sure I use a radius of 3. So area equals pi times 3 squared. Well, if I leave it in terms of pi, 3 squared is 9. I copy the pi, and this would be inches squared because we're area. If I was going nearest tenth, I would multiply 9 times pi, which will give me 28.3, and then I would have been inches squared. All right, so in terms of pi, don't multiply the pi, clean up everything else. If it's nearest tenth, go ahead and multiply it all the way through. All right, now let's look at some ways we can work backwards rather than just plug it in, because it's a fairly easy formula to plug in. This says find the radius if the circumference is 18 pi. So they're telling us their circumference right now. All right. Then they want us to find the area of this. So before I can find area, I need to find the radius by working backwards. Now you'll notice they told us that the circumference is 18 pi. And I know the circumference formula underneath in a second is 2 times pi times r. I'm going to use that formula because I need to find the radius, so I'm trying to solve for r in this. Well, if c equals 18 pi, let's substitute that in, and let's set it equal to the formula of 2 pi r. Well, go ahead and solve. If I divide both sides by 2 and pi, it's going to cancel, and I'm going to be left with r equals 9. So I find my radius first by solving for r. Now, the question still wanted us to find the area. So remember, area of a circle is pi r squared. Well, if our radius is 9, I'm going to do pi times 9 squared. If I leave it in terms of pi, 9 squared is 81, and then I copy the pi, I would call it 81 pi if I left it in terms of pi. If you multiplied it all out, 81 times pi will tell you 254.5 m squared. All right, so there's a case where they gave us the circumference, and we had to work backwards. Now, the only really other way they can make us work backwards is what if they gave us the area? All right, so you'll notice in this question, it says find the circumference. So I'm going to eventually be finding the circumference for this question. They tell us that the area is 25 pi. So before I can find the circumference, I need to find the radius. Well, I know that area formula is pi r squared, and I know the area they just gave me in the question was 25 pi. So to work backwards, I can go ahead and I can plug in 25 pi for capital A and set it equal to pi r squared. Well, if I divide by pi first to cancel those, I'm left with 25 is equal to r squared. If I square rooted, it tells me a radius of 5. Now, after I find that radius, I'm going to go back and I'm going to find the circumference because that's what the question asked. The circumference formula says 2 times pi times r. Well, if my radius is 5, then I'm doing 2 times pi times 5. If I just multiply 2 times 5, it gives me 10 pi, and I could go ahead and leave it like that if I would like to, so 10 pi feet. If you want to go nearest tenth and multiply 10 times pi, which will tell you that C is 31.4 feet. All right, so there's an example of both cases working backwards. Let's go ahead and look at 2 new formulas, and then we'll do some practice. If we're trying to find the area of a sector, so you'll notice the sector is the shaded part of the region. You'll notice the formula right over here. We're going to take pi times r squared times m divided by 360. Notice r is the radius and m is the degree. All right, so we're going to leave these in terms of pi, and we'll go nearest tenth rather than hundredth. Our formula says for an area of a sector, we are going to be doing pi times r squared times m degrees divided by 360, and notice that part is in parentheses, so I want to make sure I do that. Some people like to do the m over 360, so some people like to look at this formula as this. This is the same thing, and then multiply it times pi r squared. It's up to you. It's the same thing as long as we're using each part. Now, notice in this picture, m is the degree, so here's my m, which means the other one is my radius, the 12. Let's go ahead and plug it into our formula. I'm going to go 131 over 360 times pi times 12 squared. Now, if we want to leave this in terms of pi, we are going to do the fraction first and then multiply it times 12 squared, but don't touch the pi, we'll copy that in. So in terms of pi, if I do 131 divided by 360, press enter, and then times 12 squared, I get 52.4, but remember there's still a pi in that. So we'll call it 52.4 pi m squared. If you multiply them all out, you get 164.6 m squared. All right, let's go ahead and plug in another one. Our r is 5, my m is 25, so for area, I'm going to take my degree divided by 360. times pi times r squared, so 5 squared. Again, if I'm doing it in terms of pi, I'm multiplying these two and then copying the pi. If you do that, you get 1.7 pi feet squared for the area. If you multiply everything out, it turns out to be 5.5 feet squared. You may write your answer either way. All right, so that's area of a sector. You just have to know how to use the formula. You do not have to memorize it. Now, that's when there's a part that's shaded. Let's say we have a part where it's not shaded and we just want to find what's the length of this red line. How far is this? Well, if we need to find that, we use our arc length formula. And our arc length formula is very similar to the area of a sector, except we're going to do 2 times pi times r times m divided by 360 in parentheses. All right, so again, we can write it the same way. We can do the fraction first. So for right here, I'm going to look at it as length equals m over 360 times 2 times pi times r. All right, so let's go ahead and plug it in. Here's my radius. Here's my m. So to find the length, I'm going to take 134 over 360 times 2 times pi times 8. Now, if we were leaving this in terms of pi, I will multiply all the numbers and then copy the pi. So if I multiply all the numbers that I've underlined in orange, I get 5.96 pi centimeters. If I multiply everything, 5.96 times pi, and I round to nearest tenth, it tells me 18.7 centimeters. So again, it's up to you which way you leave your answer. All right, let's go ahead and try another one. L equals, well, here's our radius, here's our m, so let's take m over 360 times 2 times pi times our radius of 6. Again, if I wanted to leave it in terms of pi, I'm going to multiply all the numbers except for the pi. If I do that, I get 1.3 pi. If I multiply everything out, it tells me that the whole thing to the nearest tenth would have been 4.2. All right, so if it says length, make sure you use the right formula. If it says area of a sector, use the right formula. All right, let's go through 2 examples and make sure we're all good. We'll leave answers both ways. This says find the area and circumference of the circle. I'll do area first. I'll do area in red. I know area equals pi r squared. So I'm going to say pi times 3 squared, because my radius would have been 3 for this problem. Well, if I leave it in terms of pi, I could call it 9 pi inches squared, because it's area. If I multiply it all out, I get 28.3 inches squared. All right, if we were doing the circumference, remember we're doing 2 times pi times r, or pi times d, depending. Either way, we'll get the same answer. The diameter was 6, so 6 pi would be my circumference. If I multiplied it out and wrote it as a decimal to the nearest tenth, it would be 18.8. All right, question 2 wants us to find the area of a sector, and it wants us to find the area or the arc length. So I'm going to do the sector in blue. Remember, our formula is going to be m over 360 times pi r squared. Remember, m is our degree, r is our radius, so I'm going to do 45 over 360 times pi times 12 squared. All right, remember, if I want to leave it in terms of pi, I'll multiply those together, and if I do, it gives me 18 pi for the area, and I'll call it u squared because there's no label. If you went nearest decimal, you would multiply 18 times pi, and you get 56.5, and we'll call it units squared because there's no label. If you were finding the arc length, L equals m over 360 times 2 times pi times r. So L equals 45 over 360 times 2 times pi times radius 12. Remember, if I left it in terms of pi, I'd only multiply the numbers, which would give me 3 pi. If we multiplied that out, 3 times pi will tell us to the nearest tenth, 9.4 units. All right, so there's area and circumference of a circle. There's area of sector and an arc length. Now we'll do some practice and then begin reviewing all the areas so far on this chapter.